Hi, welcome to IOActive's Vehicle Security Live in the Fast Lane webinar. Everyone will be on mute for the duration of the talk today. However, we will be having a Q&A afterwards. Or you can post us your questions on Twitter using the Ask IOActive hashtag. But for now, let me hand things over to Chris Valasek, who's our Director of Vehicle Security Research. Chris, over to you.
All right. Hi, everyone. Thanks for taking time out of your day to join our short webinar here today. We're going to talk about some issues in vehicle security that I've been thinking about for a while, and additionally, what we here at IOActive plan on doing about it. So, as Craig said, I'm Chris Valasek. I'm the Director of Vehicle Security Research here at IOActive. That's a picture of me to the right there, if you don't know what I look like. I'm working out of Pittsburgh, Pennsylvania. If you're familiar with the area, I'm in Shadyside, next to Carnegie Mellon and the University of Pittsburgh. There's my email. If you ever want to ask me a question, feel free to send an email along. And there's my Twitter handle if you feel the need to follow me on Twitter. I think one of the biggest questions we got when we announced our vehicle security service offering was why. Many people thought that it was quite a narrow market. You have to realize that it's not just passenger vehicles we're talking about. We're talking about trucks, heavy machinery, emergency vehicles, military vehicles. There's a lot of technology and a lot of vehicles out there. So it's not just your everyday passenger cars. That being said, technology is driving sales in passenger cars, especially with the younger generations. They want the connected lifestyle they have in their offices and in their pockets to be in their cars as well. This brings in a lot of outside connectivity to the vehicle, which brings more code, which brings the probability of there being a mistake up. Basically, the way I look at it, the more lines of code there are, the more chance there could be a mistake, right? Additionally, there are many cyber-physical aspects being added to everyday automobiles. 10 years ago, if you were to have adaptive cruise control in your car, you most likely were driving a higher-end car, maybe even a luxury vehicle. Things like adaptive cruise control are now making their way to the mainstream. There's computers in everyday cars now that take input from, say, the car's network and perform physical actions based on that input, such as braking or acceleration or steering. The mainstream nature of this technology is interesting because as someone who has investigated these types of systems, there's a possibility for an attacker to use them against the vehicle or the driver. That being said, these types of systems make driving much more safe, and we haven't seen them used in public attack yet. But I always like to research and investigate things. And lastly, why is that cars are now connected themselves, right? GM's whole fleet has Wi-Fi backed with the cellular backend. This is becoming commonplace. Cars are really our next cell phone, right? It's going to have everything we need to communicate with the outside world in it. It's more than just automotive manufacturers as well. For those people not in the know, or me previously a couple of years ago, you assumed that a certain manufacturer developed all their computers and their parts and they put it together. That's not the case. There's outside parties that really develop a lot of these key pieces to a vehicle, especially the computerized components. And sometimes you may not know what the security risk you have by putting these pieces in your car. Traditional software companies are now getting involved in the automotive space as well. I think Apple and Google are having it out yet again to see who's going to be the king of user experience inside the vehicle, just as they're now duking it out for the space on mobile devices, right? This made me think that attackers now will be familiarized with the types of technology in vehicles. Right now, everything's a bit boutique. And when I say that, I mean that they're very specialized, and a lot of people don't know about how these systems work. But mainstream attackers know exactly how Android and iOS work and have been investigating for a long time. Even if you don't have this technology in your car, right, there's third-party add-ons. When I was younger, it was popular to get, a CD player put in your car because it wasn't standard equipment when you bought it. I think, it may become more popular to add, a new infotainment system in your car that supports the latest generation of Android Auto or Apple CarPlay. Connectivity isn't limited to the vehicle when you purchase it. While some may have some form of telematics, the connectivity to the outside world is being infiltrated by, we'll say, non-automotive companies. Right? There's insurers that give you the ability to, prorate your insurance based on your driving. Telecom industries such as Verizon are getting into the telematics game. There's a lot more people involved in the car industry and a lot more people that are involved in communications and software technology involved in the car game than I think there ever has been, at least from my perception. This really led me to think about the unique positions that vehicle manufacturers are in, as opposed to, say, general software companies. There appears to be huge reputational risk for all of these companies. Brand recognition is really king, right? I think we all can recall the Firestone tire Ford Explorer incidents from over a decade or so ago. There appeared to be some issues and cars were going over. What really, I guess, surprised me from the stance of general software security is that this incident caused a 100-year relationship to break. I think it was subsequently reinstated shortly thereafter. But it made me think that companies generally involved in technology don't have this severest reaction. You didn't see Visa or MasterCard walking away from Target after a huge breach, but something like this in the automotive space, since it involves different aspects, did result in the relationship ending. And that led me to think that a failure of one brand can affect the entire industry. I know that each individual manufacturer is concerned with having their brand being the car that's first publicly breached. But it's not going to be bad just for that individual brand. It's going to be bad for the industry as a whole. Car manufacturers are always trying to improve and always trying to get you to buy new cars. That's why there's new models every year, even if not much changes on them. If there is a public breach that results in, say, some physical harm, I think it affects the industry as a whole. So it's not just up to one company. It's up to everyone involved in the vehicle landscape to be vigilant about their security. And I think people in the manufacturing industry specifically would tend to agree with that. They don't want any negative connotations associated with the modern connected vehicle. Financial risk is always a concern, and there's a potential for financial loss upon a vehicle breach, right? Attackers could, say, steal information or maybe have credit cards in there. But I think it's really concerning to people that there's a possibility for physical harm as well, and I think that's why people take it so seriously. I always say if someone steals my Amex number, it's a quick phone call. Hopefully I don't even have to pay the fraudulent charges. American Express fixes me up, and I'm good to go. But in the event of a vehicle incident, if someone were to, alter the state of vehicle when it's going at a high rate of speed, then there's a potential for financial loss. Buying a new car is expensive. It's expensive for insurance companies to replace cars or fix damage. But also, the biggest risk is personal safety, right? I think this is why vehicle security has resonated with so many people as opposed to regular cybersecurity, because there's a potential for physical harm. One of the most unique positions, unfortunately for manufacturers and especially telematics provider, is that each consumer is also a potential attacker to their corporate IT infrastructure, right? When you buy a copy of Windows and put it on your PC, it doesn't come with a VPN connection back to Redmond. But when you buy a car with telematics, or you get a third-party telematics system put in your car, that's exactly what it does, right? You're giving the consumer the functionality to communicate with your back office systems to do things like remote diagnostics or usage tracking. This puts the supplier in quite a predicament, because every person you give this to could potentially use it as a pivot to try to attack your more traditional IT infrastructure. So instead of attacking the car, they could use that device as a pivot to try to attack your servers or your routing equipment or even desktop computers. So there's, that's something that most software vendors don't have to think about, but unfortunately for telematics providers, that is a huge concern. And it really comes down to this. All these transportation companies, whether it's a vehicle manufacturer, or a tier 1 supplier, or a telematics provider, or everyone in between, they're software companies now. Traditionally they got to focus, especially on manufacturers, got to focus on safety and reliability. But now they're going to have to establish themselves as software security experts as well. And many of them are new to this aspect. Many of the communications before were assumed to be internal in nature, right? Computers talking to computers, or their machine talking to computer, but now you have this outside influence. And we've seen traditional software companies struggle with this for a long time, and hopefully that vehicle manufacturers can learn from these struggles. And it's even harder because the amount of time these assets are out in the wild is much longer. I think the average lifetime of a car here in the United States is about 10 plus years. So if there were to be an incident in a 2014 model, that means it's still concerning for a decade. It's not like Microsoft Patch Tuesday where worst case scenario it's a couple weeks and you have a fix and it auto updates. If issues are out there, they could be out there for over a decade. And right now there's no easy way to go about remediating them. I know there's steps being taken, but you have to remember, vehicles produced in 2010, which are probably long forgotten from an automotive perspective, will be out there for quite some time and may have issues in those times. Now that we've kind of discussed my thoughts on where we are from a security perspective in the automobile industry, I wanted to talk about vehicle security research from a public perspective. I made a short timeline here. There's these are the notable moments in vehicle cybersecurity as kind of I see them. I have a little typo there. It should be USC. It was the University of Southern California. They did a study on tire pressure monitoring systems and how they could potentially track a vehicle through its wireless tire communications. And they even were able to render the tire pressure monitoring sensors inoperable with radio waves as the car drove past. This was really eye-opening, I think, for some people, because something as low-tech as tire technology was communicating with the outside world, right? And this, I think, is one of the catalysts into people thinking about the communications of their vehicle. Those in the auto industry or in the security industry, I think, are pretty aware of the next two items, which are the University of Washington and the University of California, San Diego researchers. They first were able to manipulate a vehicle by sending hand messages. And then secondly, they were able to remotely compromise a vehicle through Bluetooth and cellular to eavesdrop or exfiltrate data from the vehicle, in addition to being able to physically control the vehicle. I think the video they showed was engaging the brakes, and it was quite complicated, amazing research, and really was the catalyst for the research that Dr. Charlie Miller and myself have done. They did a fantastic job, and I'm a huge fan of the research, and it really inspired Charlie and I to continue what we did. And we took it from what they did and looked at newer cars, and we published all our information because we want security researchers to be able to assist in the securing of our vehicles, which are really part of our infrastructure as a world, right? Everyone drives cars every day. And we got to look at architecture, and we went from such high level as architecture to low level as firmware reprogramming. So we tried to do the spectrum, and we're continuing our research, specifically in the areas of remote connectivity. While my little chart didn't show every instance of public security research on vehicles, you did see that there weren't many there. Why is that? One of the main reasons, and I think the biggest reason, is the cost. To do this type of research, you have to have a lot of money. If you see on the left-hand side, those are the two receipts for the Ford Escape and the Toyota Prius, respectively, that Charlie and I did our work on. Overall, $50,000, I guess, isn't a huge amount of money. It's most likely unachievable for the individual. And many times, if you're a small organization or even a large organization, it's hard to dedicate that much money for an individual project. So if you really want to be thorough and investigate vehicles, then you need to have this much money. Basically, everything is expensive. If even if you want diagnostic tools to see how, say, firmware reprogramming is done, or do some active tests to see if you can, clamp a brake caliper, we're talking several $1,000s as well. The cost of this is the biggest barrier of entry, and that's why you don't see a lot of people doing it. Luckily enough, Charlie and I started off our research with the help of the DARPA Cyber Fast Track program, and that really made it easy for us to go about doing this research. In addition to having this much money, many of the times you break things. We were able to, completely fry an inverter for the Toyota Prius, which costs $5,000 to fix. I don't think you would want to do those type of tests on your daily driver or what you're taking the kids to school in, right? So you have to be willing to spend the money and willing to break the products that you spent the money on. So it's very expensive, and that's why I think you don't see a lot of people doing it. In addition to being very expensive, it takes a lot of expertise as well. If you've looked at anything we've published all of our tools and our data and our methodology because it took so long for us to figure it all out. And there's some tools out there that do things that our software does, probably better, but they again tend to be very expensive. So we wanted people to look at this. You need to understand the architecture of the automobile. You need to understand how the computers interact. You need to understand the low-level bus communications. You need to understand firmware updates, architecture. There's so many areas of expertise that are required to be proficient in this area of research that it takes many, many months. I'm still learning every day, and I'm practically 3 years into this research project. I've never spent this long on anything in my life, so, and I'm still learning, so it takes a lot of dedication. I don't think this is something that you're just going to pick up and start doing one day. You know, we did publish all of our information to try to facilitate other researchers looking at it, but in all reality, you're going to have to do a lot of the work yourself, and you have to take the time and the effort to be experts in these areas. Ever since the research was published, we had the idea at IOActive to do this vehicle security service offering. And I wanted to make sure when we started the offering that we had goals that were aligned with our business, but also with how I feel the industry needs to go as a whole. Remember, you know, we use cars every day. I like technology. I love cars. I want to help this industry out. It's not about tearing down. It's the fact that you tear down to build up better, right? One of the first things I noticed that I could relate to was the need for cultural change. You know, I've been doing software security for quite a few years, and I saw the first time around, you know, how outside researchers and outside investigations were handled, and it really, you know, resonated with me when I, you know, we got our first responses from automobile companies with our research. You know, we're not the bad guys, but in addition to that, security has to be a priority. I think Microsoft was the poster child for insecure software for so long, because, you know, they assumed security was something that you could fix after you release something. It really took the Gates memo to change the culture at Microsoft to say, hey, security should be part of our process throughout everything that we develop here. And you know, I again don't have huge insight into the automotive world, but I hope that's the type of cultural change that's happening. And to drive that change, we put research out, and we showed that, for example, two guys in a garage with some time on their hands could create a primitive defense device, right? So if we can do that, I feel that large organizations can spend the time and resources trying to figure these problems out. And I know a lot of the pushback I get is, why create technology or put effort in for a threat that's not imminent right now? And that's probably a valid point because it is costly, but at the same time, no one wants to be the first one hit by this type of attack. And you know, I would rather start working on the problem now than try to panic at the end. It does seem like it is happening, though, right? I mean, General Motors appointed its first vehicle cybersecurity officer, Jeffrey Massimilla, which, you know, shows to me that, hey, you know, we're taking this security risk seriously, and we're going to do what we can to try to change the culture internally by having someone that oversees, you know, all of vehicle cybersecurity and not just have it be a one-off shoot of the IT department. The second goal is really to try to promote what we're calling the vehicle security development lifecycle. If you're familiar with the software security development lifecycle, then this isn't all too unfamiliar to you. You know, we are in the assessment business here at IOActive, but at the same time, we really want to try to promote the ability to think about security from the beginning and have it be continual throughout the process, right? You want to do a high-level review and try to determine who your adversaries may be, you know, and that will help you in the end do better assessments, and you're able to think about things like what would happen if an incident happened. How can we remediate these strategies? And it needs to be continuous, because anytime you change something, you kind of need to go through this process again. Anytime that you're introducing a new generation of devices, just because it's similar to, say, an old asset, doesn't mean that you don't need to kind of review everything. So it really does go ad infinitum, and it adapts as you go along. Again, we are in the business of doing architecture review and security assessments and remediation strategies. But I do understand that you may not be able to start at 12 o'clock here on our little diagram. That doesn't matter. We're just hoping that this type of thought process will start to be commonplace within the vehicle landscape, much how it is now in the software landscape. One of the main goals was being able to provide what I was calling mature service offerings. It's one thing to do a one-off assessment or look at a piece of a vehicle as a research project. It's another thing to develop methodologies and hardware tools and software tools and other methods to assess pieces of a vehicle from a reproducible standpoint. And we've spent a lot of time, at this point, a couple years, refining our software, creating, hardware devices, doing firmware extractions, reverse engineering, setting up lab benches that are capable of assessing various pieces of a vehicle. And it takes time and money and effort, as we talked about before. And I think we're making progress every day. We're refactoring tools and coming up with new methods to assess these types of devices. So each time a similar device gets easier, but at the same time each new device adds to our portfolio of things that we then become experts in. So I want our process to always mature and be able to offer that to our clients. And lastly, I personally want to continue the public information sharing. I like, public speaking. I'm sure people are tired of seeing my face at conferences or on TV, but we want to show that we are subject matter experts. That being said, this isn't our main goal any longer. When this whole vehicle security research started a couple years ago, our main goal was public awareness. We wanted people to know that we are doing this research. We're now experts in these areas. I don't think we need to do that anymore. I think people know that we are the experts in the automotive security arena. And I want to focus our efforts more on assisting our clients and connecting with potential clients to help them solve their security needs. And by doing that, it will generate less public information. But at the same time, I think the focus is now required to be on client work. Well, unfortunately, you can't talk about client work because we do value the confidentiality of our clients. I think the overall impact in the industry will be greater by focusing on our clients' needs as opposed to public information sharing and public awareness. I have references for all the statistics and images I've used. I'm a big fan of attribution, so I just wanted to make sure that everyone knows I didn't just rip off the images. These are links to all the pages I pulled them from. And with that being said, I wanted to thank everyone for taking time out of their busy day and have a good morning, good evening, good afternoon, depending on where you are. I'd like to keep these things short. And if you have any questions, you can email us at info@ioactive.com or use the Ask IOActive hashtag on Twitter. I'll be sticking around there till about noon answering any questions. If you're not a big fan of asking questions in a public forum, there's my email address. And please feel free to send me an email. While I'm still doing research and can't talk about everything, I'd like to be a point of reference. If you have any question whatsoever at any time, I would like to be an intermediary between a person with an offensive mindset and those people actually developing these systems. So with that being said, thank you very much, and I really appreciate your time.
Thanks, Chris. If we have any questions, please put up your hand, and I see Kevin Bates. That's no, Kevin's gone. So if you have any questions, just raise your hand or type in the questions box. And if we don't have any there, then we can all just hop over to Twitter and take it from there.
Sounds good.
Cool, let's have a look. This is from James. Chris, how would automated testing fit into the VSDL?
We have some level of automated testing. Unfortunately, from our experiences, everything is different in the automotive world. So, each manufacturer is different, each supplier is different. So we do have some level of automated testing, but at the same time, I think we're valuing the architecture design, threat modeling starting point, and then going to a manual assessment from there while using automated tools.
And then from Germay is, how much security research is feasible when the internal architecture of vehicles is not disclosed to the public by car manufacturers?
It all depends on your budget, I guess. I haven't came across other than I think Tesla, but I think every vehicle has some internal architecture diagrams that you can derive, be it that wiring diagrams are necessary for mechanics to do their job. So it would add maybe a bit of difficulty, but wouldn't make it impossible.
Okay, and then, yes, Jerome, just to answer your question, we will share the presentation. We will get the team to email it out afterwards, and you can have a look at it then as well. Howard Abbey wants to know, who will hold the keys to my car?
Depends what kind of car you drive. If it's a nice one, I'll hold the keys for you. No, yeah, it's hard to say, right?
And then Michael Pittinger was here. In the early days, collision avoidance operated at K-band and would set off radar detectors and be confusing by jamming. How has this been addressed?
I don't know that much about radar, so unfortunately I can't speak to it. I know that there is, on the back end, in the network architecture side, there is a lot of messaging sent on the car's bus to perform actions based on that input. So that's the only part I know about. I'm sorry.
And then from T. Feng, he says, what's your view on the vulnerability situation in the telematics terminal device in general?
When he says telematics terminal, does he mean like the dongles people were putting in, or?
If he doesn't clarify, but yes, he says yes.
Yeah. Okay. Yeah. You add external communications to your vehicle. There's potential for security risk. That being said, saying something as general as 2 million cars could be crashed isn't a reality, right? Because again, each car is different. So even if you were to compromise a dongle, if you wanted physical control, you would need to figure out kind of each individual car. But that being said, having the ability to touch that many cars is always of a concern.
And then from James Staten, do you see a greater need for immediate security for commercial or individual vehicles?
Both. I think commercial is concerning, right, because those carry our goods and are used every day. But I think there's a lot more connectivity, at least from my standpoint, in traditional passenger vehicles.
And then another one, is how long is a typical architecture review?
It depends the granularity that you're going in. An architecture review can be looking at an entire vehicle, or it could be looking at the architecture of an individual component. So it varies depending on how granular you want to go in the review.
And then another one from John. How long is a typical ECU penetration test?
Again, it's kind of the same answer. It depends on how deep you want to go into the ECU penetration testing. If you're just looking to pick off a low-hanging fruit, not that long. If you're looking to go deep dive, several weeks.
Okay, and so a question came from Pete, Pete Bigelow. Pete, Chris and I will get in touch with you afterwards, and we can chat a little bit further. So,
cool.
Pete,
hi, Pete.
That's Craig. Hi. So I just want to say thank you to everyone for joining us. We will jump onto Twitter now, so if you have any questions, join us over there, and we can keep the discussion going. Otherwise, feel free to email us at info@ioactive.com. And